Hi everyone, Assalamualaikum. Thank you for joining and having us in here in the second International Conference on the Tropical Meteorology and Atmospheric Science. Before that, I would like to introduce our team. My name is Yochiokta. I'm from Erasmus Mundus Joint Master Degree Programs in the University, Liège, Belgium. And my colleagues are Ratu Almira from the Graduate School of Science, Department Geophysics, Tohoku University, Japan, and Hasti Amrih from the Indonesian School of Meteorology, Climatology, and Geophysics, Indonesia. We would like to present our study about multivariate DINOF reconstruction for creating long-term cold-free sea surface temperature data records with a case study in Lombok Strait, Indonesia. The background study of this research because we see a long-term reliable satellite temperature data record is requisite resource for monitoring in order to understand the climate variability. However, we still found the gappy data due to the missing data caused by cloud coverage problems, sun gleam, satellite tracks, coastal marks, or rain contaminations, which affected on the data we have been retrieved. Moreover, combination of multiple satellites products it sometimes need a statistical analysis to do know about the data which have been obtained, and some missing values still has affected on the data. Therefore, some reconstructions of the data have been done, such as the spline interpolations or optimal interpolations. And recently, Beckers and Rickson's IDA Alpha Zera, they described the new technique for filling the missing data using an EOF, empirical orthogonal functions based algorithm, with a call by the data interpolating empirical orthogonal function, or abbreviated as a DINOF, that have been developed to deal with the recovery of missing data. The difference between the OI and DINOF is if we are using OI, it's more arbitrary choice of the final grid. Whether for the DINOF is initial grid is in the final grid. So the OI usually to be in the local approach due to the size of the problem to solve. From the DINOF, it can be applied in the global reconstructions. This is also the advantage of the DINOF over the OI. If the OI sometimes needs prior informations for doing the reconstructions, this information such as error statistics of the data and the teleconnections sometimes ignore the OI. Whether for the advantage using OI, sometimes having the better representations of the small scale features. Here, I would like to give some explanations more about the DINOF concepts. The first, if we are using this spatial data, the grid sometimes has informations about color for the data. And in this color, we use the single value decompositions to get the good value of each grid and determine the optimal numbers. And after we put it into the empirical orthogonal functions of the each of the SVD, and this EOF tends to minimize the error between the real data and the reconstruction data by doing the cross validations. And the cross validation data will reintroduce into the matrix, and we do the interpolating and by the truncated of the SVD data, we will attempt the final reconstructions and having this complete spatial data. It is worth to be noted that the reconstruction method for GAPI data based on the EOF decomposition itself. So there will still be a missing data, but an iterative process will overcome the missing data problems, which are calculated iteratively and the whole matrix of the missing data. The method it's integrated data only, so the 3D matrix informations used to infer the missing data value. The DINOF also parameter free, so no need to prior information rather than the OI. So this information is often subjectively determined, and the DINOF parameters, the necessary information is obtained from the EOF basis. DINOF also resolve time and space. Whether for the three-dimensional data are used, the correlated information in space and time is used to infer missing data values. More information you can see in our reference of the Pekka-Rickson and also Ida Alvira. So here, the first attempt that we have been done is by dimming the matrix of a missing data flag and set to the 0 using the truncated of the singular value decompositions with a matrix of x equals to u as feed per t, where the u is the spatial patterns of EOF, since the V value is the temporal of EOF and S as the singular values. And we need to consider that the some data are put aside for the cross validations. After we retrieve the dominant matrix, we put it into the EOF decompositions, where the N value is represents of how many numbers EOF have been done. Like we put it in this to do the calculations with these equations of X are sum of the USV. And these calculations by this equation can improve the quest of missing value, and doing the convergence to get the best value for the missing data with the one EOF had several how many errors value that have been got for these cross validations. And we will put it again into the second EOF and doing the same guessing missing value calculations. And this process will be repeated until we got the less error value. So it's mean if we are get the less error value, this is the optimal number of EOF. And for the multivariate DINOF, it means that if we are using this metric of equations, we can put it into these reconstructions of the new metrics, where in our research, we tend to use the two-dimensional metrics of XS as ephemeral data and CM from the data from the CMMS SST metrics. We doing this research over the Lombok because we seen that still less study in the tropical area, where the tropical area tends to having a lot of cloud and several sun gleam. Therefore, our objective of this research is to reconstruct the sea surface temperature data in the Lombok Strait to prove the possibility of the DINOF method can be used in the most cloudy area in the tropical sea. So the data that we retrieve is from this longitude and latitude over January 2019 until the November 2020. The data was in the daily mean sea surface temperature from multiple satellite sources, and the data is in the global grid over 0.1 cross 0.1. This data from the IFRAMA France global sea surface temperature and from the global ocean surface temperature level 3 observation from the CMMS ESA. After we gain the data over 235, the dimensions of the file is in the 51 and 50. In the temporal data of 579, we get the mean value of the SST is 28.47 degrees Celsius with the standard deviation is a 1.37, which is quite good. And after diffusions and covariant metric activated with the parameter alpha 0.1, we get the number iteration is 3. And in this temporal value over this time series, we have a sum of the missing data up to 100%, but more of them is less than 10%. So it means that reconstructions can be used or applied by using the NOF in here. And if we are take a look for the missing data in space, the colored mean the how huge the percentage of missing value, whether for most of the missing value are in the coastal area. For the ocean area, is still less than 10% of the missing value. So it can be said that 58.16 of the missing data can be taken out to do the next cross validations in order to fill in gap of the missing value in this reconstructions model approach. Here, the grid maps of the land sea max because the DINOF can be only can be used in the grid map. So we make the longitude and latitude of the initial data. And this is after the EOF that have been done. And we found that the interpolations of EOF itself, it is in the optimal where the EOF value is in the 42. Why 42? Because in here, as we see in the error value, is in the 0.25, whether for the EOF number 43, it's become larger. And from the started, it's 0.7. It's become depleted until the optimal numbers of iterations is in the 42. After we are getting the EOF mode and getting the optimal number of cross validations here, we can see here for the EOF number 2, the constructions will be like this over the temporal, with still having some huge missing value, but more or less they are still have a good data. And after we trying to compare with OI, the result it's more reliable. It's become more reliable to the real data, because if we see in the OI, the trend it's tends to be similar with the DNOF value. So therefore, we conclude that the DNOF is reliable and quite easy to use the technique to reconstruct missing data, which wide variety either for the univariated or multivariated approach. This research will successfully reconstruct the data for the Lombok Strait data as a study locations from the January 2019 until the November 2020. This reconstruction also showed the missing data up to 58.16%, including data put aside for the cross validations after 42 iterations, which has the convergence achieved up to 0.98. We would like to thank and give this acknowledgement to the GHER, Geohydrodynamic Environment Research from University Liège, Belgium, because have been developed the algorithm of DNOF, and thanks to the ephemeral and CMMS, which have been give us this data. And this is our reference. Thank you very much for your attention, and thank you.